Okay, so the last part of solving equation is logarithmic equation. So for logarithmic equation, so solving for equations involving logarithm normally requires changing of the equation in the form of logarithm with the same base. Okay, for example, find the value of x for the equation 2 to the power of x minus 1 equal to 3 to the power of x. So this is indices, but to solve this question, we have to apply logarithm. So what we should do, we just put log on both sides, taking log on both sides. So we have log of 2 to the power of x minus 1 equal to log of 3 to the power of x. So because we didn't put any base here, so we assume it's a common logarithm, which is log to the base 10. So directly we can use calculator lah. So how to solve for this one? We just have to apply the law, which is this power can be the coefficient of the log also for this one. So what we have later is x minus 1 log 2 is equal to x log 3. So how to solve for x? We have to group the x together. So we have x minus 1, expand everything, sorry, we expand. So we have x log 2 minus log 2 equal to x log 3. So we group together x on the left side. So the right side we only have value. So what we can do is to factorize the x. So after factorizing the x, what we have is x multiplied with log 2 minus log 3 equal to log 2. So x is log 2 over log 2 minus log 3. So just use your calculator directly to find the value. So x equal to negative 1.7095. Okay, for this part also we have to check whether the answer satisfies the question or not. Anything related to log. Using calculator. Okay. Example 5. Find the value of x for the equation log to the base 3 of x minus 4 log to the base x of 3 plus 3 equal to 0. So if you notice, this question is a bit different from what we have in the book. So please change into these questions. So because I want you to use the change of base technique in these questions. So how to solve for this one? So if we notice, we have log 3 here, but this one is log x. So what we need to do is we have to apply the change of base. Okay, so not log term must be on the same base. To solve equation, we have to make sure the log have the same base. Then only we can solve the. So for this part, it's easier to change into base 3 instead of base x. So we change the second term into base 3. So we have log base 3 of 3 divided with log base 3 of x. So what is log base 3 of 3? So this is the properties of log, which is equal to 1. So what we have is log base 3 of x minus 4 over log base 3 of x plus 3. So to get the nice equation, what we can do is multiply everything with log base 3 of x. So what we will have on the first term will be log base 3 of x square outside of the log. So we put bracket here, not on the x. And then minus 4. We don't have this denominator already. Plus 3 of log base 3 of x equal to 0. Why 0? Anything multiplied with 0 will be 0. So what we can do after that, we just use the substitution method where y equal to log base 3 of x. So this term will be y, this one also will be y. So we have y squared plus 3y minus 4 equal to 0. So this is a quadratic equation. So everyone can solve quadratic equation. Okay, so what will we get after we factorize the quadratic equation? We have y plus 4 multiplied with y minus 1 equal to 0. So what is the answer for y? So y is equal to negative 4 or y equal to 1. Is this the final answer? No, because we want to find x. So replace back y with the log to the base 3 of x. So what we have is log to the base 3 of x equal to -4 or log to the base 3 of x equal to 1. So how to solve? We just change back this log form into index form. So what we have, the base x is equal to the base of 3 to power of -4 and the base of 3 to power of 1. So we have x equal to 1 over 81 or x equal to 3. So after checking, we will have the final results. So I checked these two answers. So both are the answer for the questions. Okay, for the next example. And the last example for this lecture, find the value of x for the equation of 3 natural log of 2x minus 4 equal to 2 natural log of 2x. So how to find the value of x for this one? Okay, so we can rearrange everything because this natural log of 2x is the same as this one natural log of 2x. So combining these two natural log together, so this is the coefficient on this, so we subtract the coefficient 3 minus 2, so we have 1 of natural log of 2x, so we bring 4 on the right side. So this natural log of 2x is equal to 4. So how to solve for this one? This natural log is equal to log to the base e, so we can apply the indices for this part. So what is 2x? 2x equal to e to power of 4, this base to power of 4. So x is equal to e to power of 4 over 2, which is equal to 27.299. You can leave your answer in this exponent form. So that's all for lecture 1 of chapter 2.